Good day. Welcome to another session on free body diagrams and formulating the equation of Newton's second law of motion. So today we are having this simple diagram. So this should be just simple to solve. So let's hear the statement and then we'll take out the important information from that. So this is saying a 5 kg trolley is at rest on a rough inclined surface. So already we have heard that it is a 5 kg block, so it means that it is having Fg, and it is at rest on a rough inclined surface. So if it's a rough surface, already we know that there is also frictional force, and again it is on a surface, so it will have the normal force as well, which makes an angle of 30 with the horizontal. A constant force is applied, so already we know that there's a force that is being applied there, causing the trolley to accelerate up the incline for 2 meters at 0.45 meters per square second. So ignore the effects of rotation of the wheels and air friction. So now we can see that we're having 4 forces that are affecting this object. So now let's see how we can draw the free body diagram and also formulating the equation. So drawing the free body diagram, we start with the object, which we represent by a dot like that. So we know that there's normal force. Normal force should always be perpendicular to the surface. So this is perpendicular to the surface like that. So this is our normal force. So in most cases you just have to show the arrow on top to show that this is a vector, right? And you also have gravitational force, which is always perpendicular downwards. So this will be our Fg like that. And you also have the force that is being applied parallel to the surface. So this is our force applied like that. And we already said that there is also frictional force because it is on a rough surface. So we are going to have our frictional force like that. So these are the forces acting on this object. So this is the free body diagram of this object like that. So now let's get to formulating the equation of this object. So now how do we formulate the equation? So before formulating the equation, we can see that the Fg is acting at an angle. So already we know that there will be Fg perpendicular and Fg parallel. So let's just show that. But I already said that this Fg perpendicular and Fg parallel, there's no need for you to show that on the free body diagram. So this is just for you to know that these forces, they exist there. Fg parallel. So now we can see that all the forces that are acting parallel to the plane or parallel to motion, because this accelerates up, so it means that this forward force will be acting as our positive force, and everything else parallel to this that are in the opposite direction, they'll be negative, right? So we're having 3 forces acting parallel to the plane, so it's 1, 2, and 3. So now to formulate our equation, now we start by saying our F net is equals to mass multiplied by acceleration. So what is our F net? This is our force applied plus frictional force plus Fg parallel is equivalent to mass by acceleration. But now these are in the opposite direction, so this becomes force applied plus minus frictional force plus minus Fg parallel becomes mass by acceleration. And don't forget how we find our FG parallel. So finding our FG parallel, we use FG parallel being equals to FG sine of theta. So FG, we can also represent FG by just mg. Don't forget that. So this is how you can formulate your equation. Very nice, right? So again, please subscribe to our channel so that we can keep growing and also keep on making videos for you. Have a lovely day.